Hello, everyone, and welcome to today's Saratech Enablement session. My name is Andrea Hall, and I'm the Customer Relationship Manager here at Saratech, and I'll be your host today. Presenting today, we have Chad Evans, who's an applications engineer here at Saratech, and he will be talking to you about what is some of the new things that were released or being released with Solid Edge 2020. Today, he's going to be focusing on the mechanical design side of things. Our sessions run about 30 minutes each, and they are all recorded and posted to our Saratech YouTube channel. Make sure you check out our past sessions there. Twice a month, we meet right here to learn about tips and tricks, new and old features that'll help you in your everyday tasks. And just a reminder, if you have attended our sessions before, you know that this is an open forum. So please feel free to type in your questions and your comments in that questions box over on the right-hand side in the panel. And I will try to find some time to interrupt Chad while he's speaking and just let him know about your questions or comments. You're also welcome to save those until the end. And right after our session, we will have a quick little survey if you'll just let us know how we did today. And you can also give us suggestions for future sessions. That would be wonderful as well. And while we are just focusing on the mechanical design side of things today, there were other updates, obviously, to Solid Edge. We just chose the most popular one for today, and we will try to elaborate some more with further videos in the future with everything else. But with that, I'm going to go ahead and pass it along to Chad.
All right, thanks, Andrea. Just like Andrea said, my name is Chad Evans. I also have my email that is posted right there online at the time. Andrea noted that we chose mechanical design to show that portion of it. All the portions are very long. I mean, this could be like a week's training sessions, but we threw a bunch of stuff together on the mechanical design side to show you exactly what's new, what's available today that's coming out with Solid Edge 2020. But also what has just recently come out with the Solid Edge 2020 is some of the 2D nesting, big enhancements on the Cam Pro, the modular plant design, and the PCB, which is a circuit breaker design or circuit board design, and then the tech pubs, the technical publications, and the wiring harness design. The wiring harness design has been revamped in 2020. So if you want to, shoot me an email and I can send you information on those areas or some videos on how Solid Edge looks like in 2020. Or we can put a demo together for you and follow up with you. So some of the highlights we want to cover today. The first portion is going to be with the sheet metal, looking at the lofted flange. Within the lofted flange, we're going to look at the triangular control options, the real bends, the vertex mapping, the bend table entries, and some of the other enhancements. And then we're getting into the bend bulge relief, so you can see the different icons that are available. Then we're getting into the assemblies, where the find the components is new with 2020, and also the assembly performance mode. Then after that, we'll look at some of the next generation. So next generation is going to be remeshing for mesh bodies, our line mesh bodies, the coordinate systems, and our section sketches. And then lastly, we're going to get into the other parts is the auto scale sketch and the compare models. And then part of the assembly, the continuation, is getting into count the number of bodies. So there's a big enhancement there. Prevent accidental placement of components from assembly pathfinder. The assembly performance improvements, relationship repairs for the frame and pipe commands, and section by plane. Then next section we're going to look at is parts of the rectangular pattern and sketch and profiles, circular pattern and sketch profile, the reference instance selections, maintaining the cross selection shape and sizes, the multi-face selection for the PMIs, and support solid to solid intersection and intersect command. So the last part is the next generation with the repair meshing. And the last section we'll cover is the draft for the 2D geometry, display performance, and the show hold table origin. So the first part we're going to get into is the lofted flange. lofted flange. So you can see at the top here, that is actually a picture of the icon and what it looks like in Solid Edge 2020. So our previous versions of Solid Edge gave us the capability to create lofted flanges. But to achieve those bend lines, the user would have to go into the bending method tab, okay, and then select the option to use triangulation, and then single option for the number of resultant bends. So you can see here now with our lofted flange options under our general, this is what our picture looks like for our bend relief or the extend relief and the corner relief. And then next, the bending methods. So here we have that use triangulation to develop each blend. So we put that under the options. So next, the bend tables would only allow you to pick up to 2 bends, whether you use the bend lines or not. So the bend marks were only written in DXF within the sheet metal environment. So you can see our bend table shows us our sequence. Here's our number 1, number 2. We can actually even reorder those and what our angles are. So next, the manufacturability enhancements. So the Vertex Mapping breaks a lofted flange into planar or transition regions. So you can see here's our transition and our planar regions. So you can see where it breaks in between the two. The transition regions are manufactured via bump bending on a press brake, or improve algorithms handled in a much wider variety of cases, producing a flattenable and manufacturable results. Our manual vertex mapping gives the user the ability to create designs that would not be possible via algorithm, and freedom to control the shape of the lofted flange. So such cases as one-to-one, one-to-many, arc-to-line, symmetrically, asymmetrically, parallel, non-parallel, and many more are much easier to achieve. So we threw some examples up there using the lofted flange command. So some of our bend line options. So the expandable options are now available for users to define how many bend lines are placed on a conical or cylindrical transition regions. So you can see here under our window here, so we've got the bend line selected. The number of resultant bends are 10. So some of these parameters are used to calculate the number of the bends on a larger radius size of the flange. So you can see here in the middle, what is my A and my B and my C dimensions? So if I calculated 10, it's going to give me what the angles of the segments are, what's the length, and what's the height. And then the next slide is going to show me what my bends are. So my bending methods, so you can see here, I've highlighted it in red, what are my bends? So the bends options create the real bends between the planar faces or planar plates. The triangulation options are the same as for the bend line option, except for that this option, the user defines the number of segments in each input. So you can see here, what is my number? So the last slide we had 10, this time we've got 20. So next we get into some of the bends options under the lofted flange. When we're using the bends options, the system generates bends may be added as needed to prevent twisted planes and create a result in flattened accuracy. So you can see here down below, we've got no generated bends in the middle. We're over here on the right-hand side, we've got the system-generated bends going through the parts. Okay, so in this example, it shows the middle arcs of one with no system-generated bends had the same sweep angle. Excuse me. So some of the manual vertexes can be used with the bend options, but points defined by the user will be moved to the nearest triangulated vertex. Otherwise, the triangulation would become invalid. So you can see here over to the right-hand side, what is my initial result and what is my final result. So what we did is we added that manual vertex right in the middle and gave us our end result over here. Okay, so the system generates bends are only present if the input cross sections create a face that are non-planar, cylindrical, or conical. So next, the automatic vertex mapping algorithm helps to achieve better creation success rate without user intervention. So you can see here the lofted flange options. So too many real-world combinations to make the automatic method work 100% of the time. The manual vertex mapping gives the user the ability to fully control the parametrization of the lofted flange. And then next we get into the vertex mapping, where a user can add new sets by clicking on the add button or the right mouse button of the graphic windows. So when adding new sets, you must select 2 points from the cross sections to be connected by the vertex mapping. If you right click twice in a row, the first right click will be added a new set, and the second will accept the changes and close the dialog box. So what I'll do is let me show you a little video on this so it's a little easier to spell out.
Let's go quickly back over to vertex mapping. Now, in some cases, you only need to create a set of, map sets like I did here, and it straightens out the whole model. But if you want to do more than one, you don't have to come over to the dialog box. For example, if I want to create a new vertex map, a right mouse button click. Notice it added set 3 with just a single right mouse button click. So I can click here and I can click here. If I right click again, I can click here and click here. So by right mouse button clicking, I can add new sets without going back to the dialog. Now, if I don't want that last one, obviously I can delete it. And then if I right-click twice, it's going to dismiss the dialog and create the lofted flange. So a single right-click will add a new set for vertex mapping, and 2 right mouse button clicks will dismiss and create the lofted flange for you. But that's just kind of a quick user interface demo that I thought I would share.
All right, so you get the idea. So now that what he's talking about, the vertex mapping sets can be deleted either by selecting them from the dialog or clicking on the delete button. So you can see during the video, he actually can select the delete button. So next, the user can partially define the vertex mapping for the areas they want to control and let the command automatically figure out the rest of the mapping. So you can see the auto release option. So if you see over here on the right-hand side, the auto release option, we have a linear, spherical, okay? So you can see here the different options. What is my linear? What is my circular? Or circular with trim ends plates off. So you can see where it goes right to the point. Okay, it doesn't trim. So here we've got the check mark with the trim on, and that's why it gives it to you there. Next, we get into bend tables. So improves to provide needed information in the manufacture of lofted flange. The previous behavior when using the bend table with the bend lines, so you can see here on the first example what it looked like beforehand, and then the bend lines now can be listed individually. So here we can list them individually and what our lofted flanges are. So you can see the different vertexes 1 through 8. So the bend lines and transitions are reordered as a group. Reordering will reorder the group. The user can manually overwrite the angular fields. So you can see here where they're highlighted in yellow there. So you can actually go back in there and make changes to that. What I mean by that, you can overwrite the fields of marked and update it with those change. So next, the draft bend table will reflect the improved made in the sheet metal improvement. So you can see here, this is my flat. So when you do my flattened part, it gives you the bend tables and shows you what the angles are, the directions. The next section we'll get into is the bend bulge release. So the bend bulge is a model deformation that occurs when metal plates are bent There is more evidence in a part with larger thickness and a small bend radius. The deformation is not shown in the bends created in solid edge sheet metal parts, but a need exists to create a relief to deal with them during manufacturing. So this was an enhancement that people were asking for. So as you're working with solid edge, if there's things that you really like to see, please let us know so we can turn those into Siemens and we can create options like this. So the new bend bulge release command will add relief to a simple bend ends where it is needed. Where in the past, you put this on a brake, you need that little bit of relief there so it doesn't split the sheet metal. The user will select single or multiple eligible bend ends and define the relief parameters. So you can see this is our options here. How do y'all want it? Do I want it to be circular, U-shaped, or V-shaped? So you can see here on the next screen, it literally shows me what the three options are. So you can see here's my circular, which has a nice circular, my U-shape, where it looks like the U building inside the sheet metal part, or my V-shape. So it has a nice V there, right there in the bottom. And then with the bend bulge release, it shows me here, I can move my cursor to the left of the bend and it will highlight that to the middle or the right side. Okay, if it's a good bend, it's going to highlight in red. If it's a bad bend, it's going to highlight in, or if it's a good one, it's going to be green, which you can see there, it had a nice green relief. And if it's bad, here, this is telling me I need a relief. So one thing about the prompt bar with the bend bulge release, always look at the prompt bar because it's going to tell me to select the bend ends. To apply a relief, press A to select all eligible bends, or S to select similar bends, or Control-click to deselect, and define the relief parameters in the options dialog. So the computer is always going to tell you exactly what to do. Next, we get into our assemblies. So find our components in assembly. This is a big one that a lot of people were asking for. Hey, I'm looking for a part, so now I can do a find component. So you can see up above, here's my icon. If I put my cursor right on top of it, it tells me it finds and selects components whose properties match the specified criteria. So a large assembly performance mode 2. This is where we get into parts that are very large. I know in the past I was working with Mack trucks, and they had, we'd load up a whole semi truck into solid edge, and the performance would slow down. Now we can add the large assembly performance to it, and they'll load a lot faster. So the new high performance mode for large assemblies to improve interactive performance. Several displays and interaction settings are forced to improve the performance and memory uses based on best practices for large assemblies, automatically activated as assembly size grows. The assembly enter mode based on total component count settings. So you can see down below there, it says use large assembly performance mode when the total number of components in the assembly exceed 5,000. And you can specify whatever you want. Okay. So several of the view tab settings. So if I come over here under my solid edge options and I go under view tab settings, they're inactive on performance mode when are inactive when performance mode is turned on. So you can see here, everything I've highlighted in red becomes inactive. So especially like showing hidden lines, showing shadows. I mean, those are big things. Next, we've got on the assembly tab settings, when are inactive, when the performance mode is also turned on, as you can see here, show dynamic movement, dim surrounding components, and inactive the hidden lines and unused components. So you can see there's 3 areas there that get turned off when the performance mode is turned on. So the display settings in the view overrides are disabled for improved performance. So you can see here under the view overrides, we got the silhouettes and the floor reflections. Because I don't want to see the bottom of the part, because if I've got a very large assembly turned on. So some of your floor reflections, their floor shadows, the sharpness, the view transitions are all turned off and disabled. as an assembly grows in size, to do additional parts being added and part count exceeds the specified size for large assemblies in the large assembly mode will automatically turn on when the message is shown. So it's going to show you this message once you've exceeded that 2,000 parts. Okay? So you can see here, what is my limit? So here I've got down below in the next window, it's showing me that I've got 1,456 parts that are there. And then I've got unique parts of 697. So as I'm building my assembly, it's going to prompt me, hey, you might want to put this in performance mode. So you can see here we've got before with previous versions of Solid Edge, you know, what was our frame rate to frequency of the grinder. So we were at 41 hertz. And then now after with 2020, we're at 67 hertz with the performance mode turned on. So that was an increase of 163%. Next, with the cheese factory, we've got an increase of 200%. So that was a very large one. So next we get into the remesh. So the remesh was a big one, big enhancement with the 2020. So the remesh command can be used to improve the overall quality of mesh bodies to optimize it for the reverse engineering command. So what's available in synchronous and reverse engineering tab and the cleanup mesh group. So you'll see the new remesh command as you move forward to 2020. So by selecting the mesh body, the target, the minimum, and coordinate tolerance shows the average size of the mesh across the model. So you can see here, my top model, you can see the target size, the minimum, and the coordinate tolerance is there. But if you want to decrease the mesh in size, you might key in the following. So they're telling me here, I might want to reduce the target size of 4 mils. But hey, I can also refine that even more to my target mesh of 0.78 with the minimal size of 0.39 and the coordinate tolerance of 0.008. You can see the mesh there really tightens up. And also the size decreases. So on a remesh quick bar, this is what it will look like. What is our curvature refinement? I retain the sharp edges icon and the retained boundaries. So you can see here, what are some of our examples as they're turned on and off? What is my curvature refinement? If I've got it turned off, you can see it's very blocky. If I turn that on, it has a nice smooth with the meshing. Retain my sharp edges. So you can see here up top, they're a little, a little staggered. With them turned on, and nice and sharp, and the retained boundaries. So you can see here, retained boundaries. It's very close to each other, but it is a little bit, better performance there. So what is some of our minimal face qualities? Is the value ranges from 0.001 to 0, with 0 being the worst and 1 being perfect. So our surface growth rate, this control determines the rate at which a face edge sizes vary from one face to the neighbor. And our sharp edge angular tolerance, the angle tolerance is used to check whether an edge is sharp. So you can see here, the 3 icons right above is what we were just talking about. So one other option was the remeshing. So you can see here before we remeshed and after we remeshed. So the increase is very nicely. And same with the automatic regions turned on. You see before and after. Some of our scan data. So here's a scan data that we brought in. And the scan data is, let's accidentally hit something. So you see the scan mesh is very dense, and reverse engineering command will take a lot of time to operate on this model. So you can see the scan data here, 150 meg. But if I remesh it, the mesh density can be reduced by using the remesh command, still retaining the shape of the model, but the size has been reduced from 150 down to 20 meg. So that's a big one there. So better automatic region recognition. So some of our generative design parts, the mesh is, you can see here, our generative design model, our original part. And then here we've got the mesh at the preserved regions is not uniform. And so the regions are not automatically recognized. Must have a timer turned on. I apologize. So So next, so you can see after we remesh the model, it will make the mesh uniform, and then the automatic regions will be much better detected. These regions can then be used to assemble the assembly model. So our next option is our line is almost wrapping up here. We've got a couple more minutes. So Align is our next new icon that came out. So most of the mesh files are created by scanner software, and scan data are aligned to the coordinate system of the scanner software, or they may not be aligned at all. So when imported solid edge data, they're not properly aligned to the base coordinate system, which means that the standard views are not useful to the view of the model. Currently, the aligning the models to the base thesis, user has to do a lot of steps and still won't get the perfect alignment that is needed. So the alignment is more difficult for the mesh models, particularly the scan mesh data, as they do not have face and edges that can be selected for alignment. This feature has the ability to quickly align the mesh models to the base thesis or the selected thesis. So you can see here our align option here on our toolbar. So the align mesh body using the from or to coordinate system. So you can see here, we got the from or to. And what is my principal data, the principal axis? Or I can use the best fit bounding boxes or use our custom bounding boxes. So we've got a couple examples here. So here's what it will look like from the principal axis up above. So from or to. And then we got the option using the custom box. So here we've got a box here. We're using it from and to. And then our principal axis option. So you can see here is I'm changing my axis system from the to. So you can see here where it was on the original, where I want to make it to. Now I've moved it. We've got the best fit bounding box option. So you can see how is it best fit within our axis system. Using our geometry reference option. Using the custom box option. The next part is the section sketches. So this can be found in the synchronous under both the surfacing and the reverse engineering tabs in the curves groups. Wrapping up, let's see we're at 1:30 right now, so give me a few more minutes here. So you can see with our section sketches, the big enhancements here where the user can define what sketch entity to recognize. Next, we get into multiple bodies or multiple planes are allowed for sketching. The auto scale sketching. So the auto scale sketching for all sketching geometry at the same ratio from a single driven geometry. That is now coming into play. So you can see here I've got my auto scale sketching where the dimension values are all given to me all at once. Okay, we got into a compare models. So the compare models option is very nice. So I've got a little option, a little 2-second video to show you the comparing. So you can see you can generate reports on the comparing my models between my parts, my sheet metals, my assemblies. Okay, and then let me show you a quick little video here.
And I'm going to go to Tools and run the compare. And then what I'm going to do is I'm going to pick an assembly, and the top level is rear axle wheel assembly. It's found under the compare rear wheels folder. And it is has a family of parts in it. So I'm going to use the knobby wheels for the first one. Reads it in, and you can see it brings in so you can look at it. And then I'm going to go ahead and pick that same assembly and get low profile. And you can see it reads them both in, and you can zoom in and out on each one of them if you need to. Now, obviously, the next thing to do is run the compare. Before you do, you can change any of these colors for added volume. Remove volume is just wireframe, and then volume common is, in this case, set to green. But you do have some report options. So if you want to change the linear units, mass, which views you're looking at, you can do all of that as well. But we'll go ahead and run the compare, and it does kind of in the background go off and open up these models so that it can actually do the compare. And so you'll see it working in the background, if you will. And then when it's done, it's going to throw up the comparison on the right queue over there. And you can see in red, added volume, and remove volume is the knobby. And then, of course, common, in this case, you'll see is the green. Okay. Now, if you want to change these on the fly, it's not a problem. Maybe you want to go cyan. You'll see it go off and modify. It's not going to re-compare. It's just going to take a minute to look at those. And then, of course, you also have an option to generate a report in HTML, 3 PDF, or Word document. So kind of cool that you can do that. You also have properties comparison, so you can look at the volumes, whatever you need to look at for in comparisons for property information. But it does give you a chance to kind of see what the differences are. And the one I didn't show you is the aligned model. So if you have two models that are generally the same, but maybe on a different coordinate system, you can pick the coordinate system for each one so that they're aligned appropriately, so then it can compare them properly. So that's it for.
All right, lastly, I've got the assembly count. So you can see here under assembly statistics, I can show the number of bodies for each occurrences in the assembly statistics. And I can see we went a little bit over today, but I just want to thank everyone for coming, and I'll turn it back over to Andrea.
Great. Thank you so much, Chad. Great job. I know that was a lot to cover in a short amount of time. So I just want to remind everyone that we will be sending out the link to this session today so that you can rewatch it if you like, or of course, share it with your colleagues. We would always appreciate that. Our next session would fall on the 4th of July. So we are not going to have one at the beginning of July, but we will be back again mid-July. So just be on the lookout for the emails on our next CES session. We'll also be posting that to our website here soon, what the topic of that one will be. And with that being said, be sure to follow us on all of our social media outlets, especially YouTube. That way you can get notifications when we post our sessions, our webinars, as well as shorter videos. I'm hoping that we can get some videos up on other features of Solid Edge 2020. If we have some time to do that before the holiday, that would be wonderful. And thank you all so much. We are going to include some information that Siemens sent us about Solid Edge 2020. We'll include that in the email that we'll be sending within the next 24 hours or so. All right, have a wonderful day. I don't see any questions or comments yet, but if you have any that you are waiting to ask, you are welcome to put those into the survey that's going to be popping up here shortly. Have a great day. Bye-bye.